Okay, so this is the briefing video for the esterification experiment. What you're doing in this experiment is you're taking benzoic acid, so you've got a carboxylic acid functional group here. You'll be reacting it with heat with methanol, which methanol is also going to be the solvent of this reaction. With an acid catalyst, and you're going to turn that carboxylic acid into a methyl ester. So this is called an esterification reaction. It's an acid catalyzed esterification, and you'll learn more about the theory of how this works through your theory modules. So the purpose of doing this experiment is to give you repeated practice of these key skills. In particular, this is another reaction that needs to be set up and run under reflux. But this experiment is also going to introduce to you a lot of new key skills that are used in synthetic chemistry experiments as well. Liquid-liquid extraction, for example, is one of the main ways that we purify mixtures in organic chemistry experiments, and distillation is one of the main ways in which we purify liquids as well. So in the following pre-lab videos, they will show you how to perform these key techniques, and also the associated theory video will explain to you, why do we do a liquid-liquid extraction? How does it actually work? How does a distillation work as well? So this experiment is a 2-day experiment. And the way that the experiment should plan out for you is through this sort of approximate sort of breakdown of the different timings of the different components. So in the morning, the session, the first part will be sort of setting up and heating your reaction under reflux. It should be an hour-long sort of reflux for the esterification to occur. And then when the reaction is finished, you'll then cool the reaction and then filter your mixture. And this will take you most of the morning, so it's a good time to sort of stop at this point and have a lunch break. Then in the afternoon, this is when you'll do your sort of first sort of purification of your crude material using the liquid-liquid extraction, and this liquid extraction will help to purify and isolate crude methyl benzoate and remove things like the acid, any unreacted benzoic acid you have, and your methanol as well. And again, as I mentioned, the theory video will explain how exactly these things will be removed through the liquid-liquid extraction. And that should take the afternoon of the first day, so you can leave your crude methyl benzoate ready for the second day of the experiment, where you will then start in the morning to purify your methyl benzoate with a distillation. The distillation can take anywhere approximately sort of 1 to 1.5 hours to complete, and then when the distillation is complete, you should have pure methyl benzoate, and then you can do your analysis straight away on the oil that you isolate from the distillation, so IR and gas chromatography. So really you're allocated sort of 2 days to complete the experiment, but really it should be a day and a half, and you should finish the experiment by the morning of the second day. But we have sort of timetabled extra time if need be. So do make sure you're familiar with all the hazards of the chemicals that you're going to be using in the experiment. They're all in the experiment script, and part of the pre-lab exercises will be to ensure that you are familiar with the key hazards associated with this experiment. If you're running the experiment and you sort of forget what the hazards of the chemicals are, or you forget how to dispose of them safely, that's okay. but do make sure that you sort of then look back to the hazard section that you do have in your experiments scripts, and you check what the hazards are, and you check what the precautions you should be taking and how to dispose of them safely before you are about to use them. All that information is there in your scripts, so don't be afraid to sort of go back and look at your hazard section in your before sort of moving on to using them in your script. This is a main summary of the hazards that you're using. So you're using quite a lot of methanol and diethyl ether as solvents in this experiment, and they're very highly flammable. And obviously you're going to be heating the methanol as well under reflux as well. So they have significant hazards associated. They're significantly flammable, so there's a significant hazard associated with using these solvents. Diethyl ether in particular, you'll be using large quantities, and it has very sort of flammable vapors, and then also you're going to be using Bunsen burners to do your distillations. So there's a key hazard here where maybe some of you are using diethyl ether for the liquid extractions. Some of you might be moving on to the distillation stage of the experiment and then sort of be using Bunsen burners. Do make sure that you're sort of aware not just of what you're using, but what people around you are using. So there's no sort of we're not mixing these flammable solvents and then heat sources like Bunsen burners closely to one another where fires can occur. Also, you're going to be using sulfuric acid, and you're going to be using concentrated sulfuric acid. So this is very, very corrosive, and you really have to make sure that you're using gloves, and you've got to make sure that you sort of are mopping up any spills and diluting it down with water as well. Okay, the concentrated sulfuric acid is a lot more corrosive than dilute sulfuric acid, so do make sure you are handling this safely. You only need a small amount to be in contact with your skin to cause a severe burn. Okay, so these are the key tips for performing the reaction. So a lot of the key tips around the reflux were the same ones that were covered in the briefing video for the paracetamol experiment. So it's making sure that you use the correct size condenser and flask, you're clamping it in the correct place, and also you're making sure there's no leaks on your water tubing for your condenser. If you are unsure what I mean by covering those points as quickly as I have, then do go back to the paracetamol briefing video, and at the end of that video, that's where I sort of cover what I mean with those points in more detail. With regards to the liquid extraction, one of the key sort of errors we see in performing a liquid extraction is if you have your stopper at the top of your separating funnel, then you open the tap, you don't see the liquid sort of coming out in the bottom into your conical flask, and that's because the air is trying to escape through the bottom. Just remember, if that happens, just to take the stopper off the top, and then that way air can get in through the top of your separating funnel, and then your liquid should pour and drain into your conical flask much more quickly into the conical flask. The other tip as well is you're going to be collecting lots of different layers of solutions, aqueous solutions, organic solutions, washes into lots of different beakers and conical flasks. You can often get a little bit confusing over which is your organic solution, which is your aqueous solution. So do label your flasks, and also make sure that you keep everything as well. Okay, so what you're trying to keep is your methyl benzoate in your organic solvent, but your aqueous solution and your organic solutions will both be of a similar color, so it can be quite difficult to remember which is your aqueous and which is your organic. So if you remember to label everything, but if you keep all your different layers until you at least get to the distillation stage, then you won't accidentally, throw away your material, which will be in your organic layer, and sort of take forward your aqueous layer by mistake, and have to then repeat the reaction if you do that. So make sure you keep all your different beakers and conical flasks with your solutions until you get to at least the distillation stage. Then you know you've got the right material to be trying to purify by distillation. And then the other thing I want to mention as well is you will be running an NMR of your final sample as well. Now, you don't need to worry about trying to analyze your NMR spectrum for your final sample. The reason why we're getting you to run an NMR sample is just to learn and understand the process of how you submit an NMR spectrum and how you get your spectra back. Okay, and so there will be instructions on the on Minerva as well for the folder of this experiment on in terms of how you should receive your spectra. So just do check that all works for you when you get your NMR spectrum. So you do submit it with your sort of post-lab submission. But yes, you don't need to worry about analyzing the spectrum. This is because you're learning this in your theory module. So we'll wait until you've completed your theory module until you have to start analyzing the NMR spectra you receive from your Priestley experiments. Okay, so that covers everything for the briefing of the esterification experiment. So now you can sort of move on to the other sort of pre-lab resources that you need to do to then complete the pre-lab test for this experiment.